for little information about this word. Here you would see contraction of this word. What? Quadri plus letters. Quadri plus letters. Now, point is what is the meaning of a quadri and meaning of letters. So remember, quadri which means four side, four. Quadri which means four. Now next laterals, laterals which means sides. I am saying side. No, I am saying sides. So four sides, and we will break down it in details as much as possible. Okay. Four sides. We are going to talk about four sides. Quadrilaterals. So this was any information about this word. In details, we will understand about it. Before that, let's understand curve. What is a curve? What is the meaning of a curve? And you see curve diagram in your real life and when you study math subject, any subject. When this word comes. Open curve, then we are looking, then we are saying what there are two types of curve: open curve, simple, open curve, closed curve. What? What's all that? What's all this? What's all this? Then here, what is a simple closed curve? Simple closed curve. Simple which means simple, not complicated. Okay, complicated. Polygons, then polygons, classification of a polygon. So let's start with the first one, which is a curve. It is said that curve. When we will start to write, when we will start to write. Okay, so here we are talking about curve diagram. So first you take a part and then you start like that. So without lifting this marker, your first point is this and your second point will end. Like that. So here first this is first point and this is the second point. And now you can say what this is a curve. This is a curve. So here this is also curve, this is also curve. Meaning of a curve says that when you start, then we have a point. This is one point. Then we started moving like that, and second point will end at somewhere. This is the second point. So without lifting in between, when we are drawing a curve, without lifting marker, either marker or pen. Second point, from first point to second point, this diagram will be known as curve. So condition is without lifting in between this making diagram, making a curve. So first point and second point, you will start them. You will have first point. Here you can see first point. Then you start making curve like that. Then you will have a second point, which will be known as end point. First point will be known as starting point, and last point. Second point will be known as end point or last point. This is how we make a curve. This is how. So definition of a curve is first point from first point to another point, from first point to second point, without lifting between making the diagram of a curve is known as curve. Okay. This was here. You also can say this is a curve. 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 This is. You also can say that this diagram is a curve. This diagram is a curve. This diagram is a curve. You can say, but our point will be something else. Here we are talking about definition of a curve and classification of a curve. We understood about the definition of a curve. Now let's talk about classification of a curve. Here you are looking open curve, closed curve. What is the meaning of open curve? Open, which means one point of a curve and second point, both will be open. Both will be open, not closed. Do you want to see diagram of open curve? First, already you know, to make a curve, we need what? A 2 point. First and second point. First, we need to start, and second, we need to end. Uh, Open curve, okay, open curve. So first point, we let's start, and we are going to make a diagram of open curve. So of course you can, let's say this. This is the first point where we started, and this is the end point where we ended. Now can we say this is a open? This is a open curve. This is open curve, of course. But this is a complicated open curve, and you can simple open curve like that. Okay, like that. Here we are looking what? We are not looking closed. This and this is open. This open. We are looking open. These are not closed. Don't worry. Let me explain this closed work. Then you will see difference between this closed curve. Closed curve, which means first point like that. First point. Okay. Yeah. One point. First of all, we will start from one point. Then end point will add this same point, which is first point. Here you can see. This was first point. This was first point, and then we started making curve like that. Then we ended second, which is last point, where at the first point. This is what this tells us, that this curve is a closed curve. Here we are not looking open area we are not looking. So both the points will be at a point. Will be diagram of closed curve. So both points should be at a point, at a place. You can say at a place. Those type of diagram will be known as closed curve. But in this case, you are looking. Both points are not at a place. First point is here and second point is here. First point is here and second point is here. This is the meaning of open curve. Open curve says that you will have 2 points. First point which you will start, and second point which you will end. But both points will not be at a same point. First point and second point. Second point will not be at first point. This is a meaning of. This is a explanation of open curve. You can see what this is open. Okay, this is open. But here you can't say that there any open area. No, this diagram is closed. And here, if you want to understand by definition, then you can say both points which are first and second point. First point which we start to draw, and second point where we end. So both points will be at a place. This is a description of this open this closed. Okay, we understood about closed curve, and we understood about open curve. I hope you understood something. Clear? And here you can see in a written form definition of open curve: a curve that does not end at the straight point. Otherwise you can say at the first point. and a closed curve that that ends at the same point, at the first point. Clear? Now it's a time to understand about simple closed curve. What is the meaning of it? Just we understood closed curve. Now, next word, just simple was added. Just simple was added with the closed curve. So now, what is the difference between closed and a simple closed curve and a simple closed curve? Let me explain so that you can be clear without any doubts. Here, simple closed curve. We understood closed curve. Here you will realize two types of closed curve. First simple and second complicated. So here we need what simple, just simple closed for this lecture. Okay, for this lecture. Complicated closed curve, which means like that. Just we understood. This is a complex complicated what closed curve. Complicated closed curve. Now, what is the diagram of simple closed curve? Simple. This is a simple. This is a simple. Otherwise, this is a simple closed curve. Here, through definition, let's try to understand through definition about the simple closed curve. Complex, complicated closed curve says us that I will intersect. Here you can see first point same. Here we are looking what intersecting what intersection. So closed complex closed curve will show what intersection. Remember. So here we are looking intersection. This is a complicated closed curve. But whereas in the case of a simple closed curve, here we want to see any type of intersecting. Can you tell me where is the intersecting in this diagram? No, this is a definition of this is a description of simple closed curve. This is also closed curve, and this is closed curve as well. But difference is that difference between them is that in the case of a complicated closed curve will show intersection. You can see in this diagram. But in the case of a simple closed curve will not show what intersecting. This is a main point. I hope you have understood. Now it's time to understand about the polygons. What is the polygons? What is the polygons? Here you can say our definition. I have written already. But a simple curve. We understood about a simple curve made up of only line segment is called a polygon. Here you will see twist. You will see. You will realize twist. What is a twist? Twist is line segment. Already, most of you know what is the line segment? What is the line? Line segment, which means we don't see arrow. In line segment. This is line segment. Both we will notice two end points in the case of line segment. Two end points are compulsory to tell that this is what it is a line segment. So two ends are compulsory to make a line segment. To make a line segment. So this is line segment. Twist. This is what is a twist. We were understanding about the curve in which we didn't notice this line segment, and now in understanding of a polygons, it is saying that a simple curve which will have line segment, and with the help of line segment will be made what a polygons with the help of with the help of line segment will be made a polygons. And you will be shocked to know that this is also a curve. This is also a curve, but this is open, simple open curve. Simple open curve. With the help of line segment, let's make a polygons. Let's make a polygon. But we can't say this is polygon. Okay, we can't say that this is a polygon. Polygons will make a polygons should have what three, at least three line segments. Then polygon will start to make what then three line segments will start to make polygons, will start polygon. Here I said that we should have three line segments, then we will be able to make a polygon. And if we have two or three or more, then we can create more polygons. But at least we should have three line segments from which we can create a polygon. And then you have a four line segments, then we can create another polygon, next to polygons, which is quadrilaterals. Okay, this is also explanation of polygons. I am not telling you unnecessary points. A simple curve made up of only line segment is called polygon. Yeah, this is the correct definition. Also remember, one line segment will not create a polygon, and also two line segment will not create polygon. But when it comes to three line segments, then of course three line segments will create polygons. Okay, will create polygons. So here, let's see proof. This is here we were talking about what curve, closed curve, open curve. Now here, curve will help us. What we understood about this sentence. Now one point more in this case. What is that? That is, we will have what closed. We will have closed line segments. We will have closed line segments, and this is the exact meaning of a polygon. Closed line segments. Okay, then we say polygons. Then we say polygons. What now you can see here. This is one line segment. Okay, this is one line segment. We started from one point, then we ended our second point, which is the last point. It is called what? Line segment. Now we have one line segment. Now let's create a second line segment. And I told you that one segment line will not create polygon. Now second. Let's just this is a second. This is second. We are going to make a polygon with the help of line segments. Now we have two line segments. Can you see here that? Can you tell me? Is it a polygon? Is it polygon? What is the definition of a polygon? Just I told you. So two line segments. Here we are not saying what closed. We are not realizing. We are not noticing that this is a closed diagram. No, of course no. And closed curve, we understood about closed curve. Closed curve will not open area. Here we are looking open. This is what? This is open curve, you can say. This is open curve. But we need a closed curve. So to make it a closed curve, then we will take what third line segment to make this diagram as a closed curve line segments. Now here you can see we have a diagram which is closed, and we took how much, three line segments, and then we have in a result we have what can we say, we have a polygon. Yeah, we have polygon. This is a polygon. This is what is called polygon. Here you can you tell me what is the name of this polygon? Triangle. Triangle, yeah, of course. To make a triangle, uh, we create a triangle with the help of three line segments. This is one, this is two, three. This is three. Then we are able to create this triangle. So now in your mind what becoming points about it, that that this is a definition, and to make a polygon, we can start a polygon uh, from three line segments, then four line segments. So yeah, three line segments we can create what, with the three line segments we can create triangle. Whereas with the four line segment, this is one, this is a two, this is a three, and this is a four. So here we have a four line segment. Suppose this is a crystal clear. In this case we have four line segments. In this case we have a three line segment. What is the difference between? When we create with the three line segments, then we can create a triangle. This is known as a triangle. But when we have four line segments, then we can create a quadrilateral. This diagram is said as a quadrilateral. And as I was telling you in the written any information about in this case what a quadrilateral, which means four side four sides, four, and laterals sides. So how much sides? Four sides. So one, two, three, four sides. We are looking for sides. This is what explanation of what quadrilaterals. Four side we are looking. But here we added some more points to define quadrilaterals. What did we add? We added that we should have a closed quadrilaterals. Closed. Okay, we have four sides, but closed. This is main point. In this case, also we are looking closed. We have three sides, but main point is closed. And our topic is about this diagram, and in details we will break down it. Okay. A simple curve made up of only line segments is called a polygon. Yeah, clear. Now let's talk about classification of polygons. Classification of polygons. Just have a look. This is known as quadrilaterals. Quadrilaterals, and this is triangle, line segments. Here you have definition. You have a two definition of a tower, and just have a look. Next point, which we are going to talk about the classification of polygons. You can say in details. We will understand. Classification of polygons. Here, these are classification of polygons. Okay, we have polygons, not polygon. Okay, first which is a triangle, the second quadrilateral, pentagon, hexagon, heptagon, octagon. Three which means three angle, otherwise we can say three sides. So here we can see three sides. Quadrilateral, quadri which means four, and laterals which means a side, four sides, one, two, three, four. But in this case, you are getting realized that we have segment, line segment. Okay, we have line segment. Remember this one. Pentagon. Here you can see penta, which means five. Gun. Pentagon. Gun, which means the sides. Penta. Five. One, two, three, four, five. Five line segments, and it will be better to say line segment, so that we it is what standard study you can say standard words to in explanation of this topic. So in a diagram of a pentagon has how many sides, how many line segments? Five segments because of pentagon. Okay, hexagon, six, of course the six. One, two, three, four, five, six. So in the case of hexagon has six line segments or six sides or six sides. In the case of heptagon has seven line segments or seven sides. In the case of octagon has how much? Eight. Octa. Eight. So eight eight sides, otherwise you can say eight line segments. 1, 2, 3, 4, 5, 6, 7, 8. Of course. Now, from this classification, you can realize, you can understand that these are these are polygons. This is one polygon, this is second polygon, these are polygons, and we understood definition of polygon. A polygon has a closed line segment curve. Closed line segment curve. So always remember, a polygon will have a closed line segment curve. These are curve, but these are curve are made up with help of line segments. Okay, clear? That's it. These are what you can remember. Then let's move to the next. Now it's a time to understand about what What is a diagonal? What is a diagonal? Can you tell me what is a diagonal and what is the figure of a diagonal? What is the figure of diagonal? So with the help of classification of polygon, we can understand about a diagonal. This is also a diagonal is also part of a polygon. Remember, it is also part of a polygon. And let's see where is the diagonal in a polygon. Let's create a polygon which is this is polygon. But in this polygon, you will not realize what diagonal. But you can say this is a diagonal. But this is not exact definition. So to understand about diagonal, let's take a quadrilateral. This is quadrilateral. Can we say quadrilateral? What is the meaning of a diagonal? As I told you, it is also a part of a polygon. But in the case, in the diagram of, in the polygon of a triangle, we will not realize a diagonal. But we can create. And in some cases, you will see diagonal in a triangle. But to understand about this diagonal, we took a figure of a quadrilateral. In this case, you can realize diagonal part. This is what figure of quadrilateral. Now, definition of a diagonal says that this diagonal is also line segment. Okay, it is also line segment, but condition is that it will start from one vertex to the opposite vertex, from one vertex to the opposite vertex. Am I telling you? A diagonal line segment will start from one vertex. I am saying vertex. So this is vertex. This is vertex. Vertex, which means points, 2 points, same 2 points. This is first point. This is the first line segment, and this is the second line segment. And we are looking what first point of this line segment here, and this first point of this line segment is here. Both the first points are at a point. That's why it is said vertex. So line segment will start from vertex and will end to the opposite vertex. So opposite vertex to this is this. So from here our line segment will start and will end to the opposite vertex. This is an exact explanation of diagram. Now you can see this is a line segment. Okay, this is line segment, and it says that I will start from one vertex and then I will end up to the opposite vertex. This is what we had to understand. Clear? Now can you tell me how many are diagonals in this quadrilateral diagram? First we draw. We have a first. Now second. This is a vertex. This is vertex. Now we will start from this vertex, and opposite to this vertex is just this. Can we create more except to this diagonal? Can we create more diagonal? No. In this quadrilateral, we can't create more diagonal after creating two diagonals. First and this. This will happen in quadrilateral figure. Now you can say that we have a quadrilateral. So can we not diagram like that? No, of course no. And you can say this is just opposite. This is not just opposite. This is not exact meaning of opposite. Yeah, you can get confused that can't we draw from this and do this as a diagonal. No. This will be known as adjustment. Adjacent. This will be known as adjacent. Okay. So here we don't need base and we don't need adjacent. Adjacent. We are creating. We are understanding about a diagonal. We are not understanding about adjacent, about base. Okay, so base is another part. This is base is another part, and diagonal is another part. Perpendicular is something else. These three are meaning of these three are in different. Okay, so base is something else as compared to uh, diagonal, and diagonal is something else as compared to base. So if you are drawing a line segment from here to till here, then this will be known as what base. Otherwise, you can say this is adjacent. Okay. Right. Now let's take another polygon. Next polygon, which is no. How many can you create a diagonal in this? Let's see. This is vertex and just opposite to this one. This is vertex just opposite to this one. And also you can create from here to till here and from here to till here. Like that. Okay. This is we will understand in details about the diagonal with equations, and when we will understand a particular polygon, for example, quadrilateral. So our chapter is quadrilateral. So about a diagonal, as I mentioned here, we have two diagonal in quadrilateral. So this is what we are going to understand, and these are extra explanation. So here you some diagonal in this polygon. So let's move ahead and then let's see what's the next. Now let's understand regular and irregular. Regular and regular polygons are so important to understand it. Why? Let's see. Regular and irregular polygons, and what's our difference between this? What's our difference between? Let me write a definition of regular. Just have a look. Just have a look. Read it and try to understand what is this sentence is. What is this sentence saying? No, regular polygons. It's a time to understand about the regular polygons and irregular polygons. And the definition is given here. A polygon having all sides equal. All sides will be equal. Okay. And angles, also angles will be equal. Will be known as irregular side, irregular polygons. So length of in meter in centimeter, length of sides, length of all sides of a polygon is equal. For example, one side is 5 centimeter and second side, length of a second side is also 5 centimeter, and length of a third side is also 5 centimeter, and as well as length of fourth side is also 5 centimeter. This is what we say all sides are equal in length. Now, as well as angles, measure of angle would be equal. For example, one angle, measure of one angle of a polygon is 45 degree. Then similar measure of a second angle will be 45 degree. Now we have four sides. Suppose four angles will be there, will be in a polygon. Four sides and four angles. So for each four angles, measure of each four angles is how much? 45 degree. Okay. Till here you understood? So it is a very simple. It is a very simple sentence. It is saying that all sides, all angles will be equal, will be known as regular polygon. For example, equilateral triangle. We understand about a triangle, types of a triangle. For example, equilateral triangle, and then isosceles. Yeah. So here, in the context of an equilateral triangle, it is just saying that I have three sides which are equal, which are equal. This is the meaning of equilateral triangle. Otherwise, you wanted to understand about the meaning of equilateral, then you can understand that equilateral, equal and laterals, equal and laterals. Laterals means sides. So equal sides of a triangle. For example, by drawing a figure of a triangle, we can understand about the equilateral triangle. This is equilateral triangle. If this is not a perfect diagram of an equilateral triangle, then don't worry. With the help of what measure. For example, this is 5 centimeter. Okay, this is 5 centimeter, and this is 5 centimeter. This is 5 centimeter. Let's name it A, B, C. Measure of this side is a 5 centimeter. Measure of this side is a 5 centimeter. Measure of this side is 5 centimeter. This is how we make a diagram of an equilateral triangle. Equilateral triangle should have all sides equal. All sides all sides equals, and already we know a triangle has three sides, 1 2 3, and sides of each sides of a triangle has how much? Equal in measure. So this is equal, this is 5 5 5 equal. So now we can say this is what equilateral triangle. Now as we understood that angles will be also equal, angles will be also equal. You can measure, then you will realize what angle is also equal, because of the sides are going to equal, that's all. So angles will be also equal. Okay, don't a square. If you want to understand about a square, a square. Most of us we are familiar. We are familiar with the diagram of a square. A square has equal sides. A square has four sides which are equal, of course. So this is a what? This is an example. This is an example of regular polygon. Regular polygon. Okay. Now a square which means 4 centimeter, and centimeter. All sides are equal of a square of this diagram, and of course what angle is what we can set our angle is 90 degree. Angle is 90 degree. Before that, let me name it. So here you can say ADC is what? Measure of angle of ADC is 90 degree. Yes or not? Of course, this is 90 degree, because of a reason is this is how we see. We see by looking at the hint. Hint is what? 90 degree. So this is a hint of 90 degree rotation. Okay. And whereas this is a 90 degree and this is a 90 degree, and right angle is also known as a perpendicular. Okay, the right angle is also known as perpendicular. So here all four measure of all four angles in this diagram is equal, which is 90 degree. Okay. So we understood about the polygons. Let's understand about irregular. It is just a opposite of a regular, a definition of regular polygons. It is just a meaning of irregular polygons. It is just a opposite of regular polygons. So let's understand polygons which are not regular. Of course, in one sentence, it is like polygons. Those polygons which are not regular. For example, a rectangle, rhombus, diagram. This is not a square. Why? Not worry. We will come on this context. This is not a square. A square says all sides of a square will be equal. But in this case, one parallel line will be equal to each other. Measure of one parallel line will be equal to each other, and the second parallel line will be equal to each other. The rectangle diagram says that measure of this side is 5 centimeter. No, 10 centimeter. 10 centimeter. Then parallel to this line is this. So of course this will be 10 centimeter. This will be 10 centimeter. Second parallel, this is a parallel. This is a second, and this is a 5 centimeter. This is a 5 centimeter. Here we can see what are two parallel and two parallel. This is the first parallel and this is the second parallel. But we are not understanding about irregular polygons. Irregular polygons say that all sides will not be equal. All sides of a irregular polygon will not be equal. Here we can see. Okay. All sides will not be what? equal. But here, angle we are looking, we can see, we can notice angles of this polygon is what equal 90 degree. But we can't say that this is not regular. This is not regular because of all sides of this polygon is not equal. That's why we can't consider it as regular. Rather, we will consider it as irregular polygons. So let's move and usually we will understand it in details. Just have a look. Now let's try to understand interior angles and the exterior angles of a polygons. Interior angles, exterior angles. What is the difference between them? Interior angles and exterior angles. Meaning the spelling of this word interior and exterior angles. Diagram. Let me draw a diagram of both angles, which is like this. Just have a look this diagram. Let's break down it, and it is very compulsory to understand it. And concept of it will come in a 9th standard, in 10th standard. So interior angles, it is saying that what is the meaning of interior? Interior which means inside area, inside area. So inside area of this polygon is where this is inside area, and this is exterior area. This is outside area. So instead of saying inside area, we say what interior. In mathematics, we are in the context of mathematics. So in mathematics, we say what interior instead of saying inside. So to understand, we can say that inside area of this polygon is also said what interior side, interior area. But outside area is said exterior area. Okay, exterior area. Now let's talk about first of all total total degree inside total degree of this polygon inside this will be how much? Will be how much? So it will depend. It will depend. So here we have how much angles? 1, 2, 3, 4, 5. So sum of 5 angles, sum of all angles in a sum of all interior angles. That will be more better to say. So sum of all angles, sum of all interior angles of a polygon will be how much? Sum of all interior angles will be how much? n minus 2. This is just formula, n minus 2, and then we will multiply with 180. We will multiply with 180. So n is a number, n is indicating number, which is also said natural, okay? Natural numbers. So here, how much? 1, 2, 3, 4, 5. So we will write here 5. So 5 minus 3 and 83 is a 54. So we have measure of all interior angles of this polygon is 540 degree. 540 degree. This is how we can find out value of all interior angles of a polygon. All. I am saying all. Not I am talking about only one angle. To find out only one angle, one interior angle of a polygon, we will apply what? We will apply only one angle. For example, this angle. Measure of all interior angles is 540 degree. Okay, 540 degree. But we want to know only one value of one interior angle. Then how can we find out? This is a first step to find out all okay. Now each interior angle. Each interior angle, to find out each interior angle, for example this, then we will subtract what? We will subtract measure of this angle from 180 degree. Each exterior angle. Then we will get measure of this angle. So we will subtract value of each interior angle from 180 degree. This is how we can find out value of each interior angle. Okay, and this is also said what linear pair. Through another method we can find out value of this by applying linear pair method. Okay, by applying linear pair method. We saw that to find out value of all angles of interior polygon, we need to apply formula which is n minus 2 multiple 180 degree. Okay, 180 degree. But in this case, to find out value of all exterior angles, we have how much exterior angles? 1, 2, 3, 4, 5. 5 exterior angles. So always remember, whatever we have and exterior angles would be what? How much? 365, 360 degree. So sum of all exterior angles, sum of all exterior angles would be 360 degree. Would be how much? Sum of all exterior angles would be 360 degree. Clear? Would be 360 degree. This is very simple. This is very simple. You have, for example, in this polygon has how much exterior angles? 5. But you can have 6, 7, 8, 9. For example, you have 10 exterior angles of a polygon. Then still you will have sum of all 10 exterior angles. How much? 360 degree. 360 degree. This is twist. You can say this is a twist. Now to find out one exterior angle, then what is the formula? What is the formula to find out one each exterior angle? So formula is what? Just we will divide. Each exterior angle. We already know sum of all exterior angles is 360, and we need to know only one. So of course we will divide. We will not subtract. We will divide. By natural numbers. How many we have? Sides. 5 sides. 5 sevens and 5 twos. So 22 degree. We can say measure value of this angle is 22 degree. Value of this angle is 22 degree. Can you say? Yeah. Whereas you also can say this is 22 degree, this is 22 degrees, this is 22 degree, this is 22 degree, because we are talking about each exterior angle. And now you can see sum of all each exterior angles. Sum of this angle, this will be how much? 360 degree. 360 degree. This is how we can check. Is it making a 360 degree or not? Okay. These are formulas. And we will have some questions based on this. So let's understand again. Sum of all interior angles of a polygon will be calculated by applying formula which is n minus 2. N, which is a natural number, n, which is a number of sides of a polygon. We will subtract 2 from polygon's sides. Then we will multiply by 180 degree. We will get what? Value of all interior angles of a polygon. So formula is what? N minus 1. We will multiply by 180 degree. Now only to find out one interior angle, value of one interior angle, then we will apply formula which is this formula. 180 minus what? Each exterior angle. We will subtract each value of each exterior angle from 180 degree. So we should have a value of this exterior angle. Then we can find out the value of this interior angle. Don't worry. We will do practice based on this concept. Now in this case, in this diagram, we have this area is what? Outside area. In mathematical way, so we say this is exterior area. Now exterior angles, how much we have? every 1, 2, 3, 5. So already we know sum of all whatever we have. We have 5 exterior angles. So sum of 5 exterior angles would be 360 degree. If you have 10 angles, 10 exterior angles, then sum of 10 exterior angles would be 360 degree. Not just we want to find out only value of a exterior angle, only value of one exterior angle. Then we will divide 360 degree by natural numbers. We will divide 360 degree by natural numbers. Natural numbers, which mean numbers of sides, number of sides. Okay, so just have a look this. I'm going to take a question. Maybe based on this concept. Question number 1. Find x. Find x. We have a polygon. Diagram is like this. 1, 2, 3, 4, 5. Pentagon. Now, find the value of x. Find value of x. X which is angle. X which is angle. Angle in math. Now, what is the meaning of this hint? This is the hint. This is hint to represent sides are equal. Sides here. Side measure of this side and measure of this side are equals to each other. So here we are looking all sides or measure of all sides are equal. That's why all a measure of all angles will be equal. Will be equal. And can you say that this is a regular polygon? What? This is a regular polygon. This is a polygon, but this is a regular polygon because regular polygon has equal sides, equal what equal measure of angle. So here we are looking x axis which is equal. Now we have how much angles, how much angles? 1, 2, 3, 4, 5 because of polygon is pentagon. Now we have 5 sides, we have 5 angles, and angles are inside of a polygon. Angles are interior. So to find out the value of all interior angles, we apply what? To find out the value of all interior angles, we will do what? We are talking about interior angle. So a minus 2 and multiple 180. This is a formula of and to find out all interior angle. And how much? 5 minus 2. Let's simplify it. 3 multiple So value of all interior angles is 540. But we question is saying found the value of x, only x. So here we need to find out what when we will apply formula, which is h interior angles, h interior angles, h interior angles, which would be what, as we know, 180 minus h exterior angles, but we don't know h value of each exterior angle, so we can find out value of this. How? Let's see. Already we know value of all exterior angles of polygon is how much? 360 degree. Okay, 360 degree. Each exterior angle. Each exterior angle. To find out each exterior angle. How much? 360 degree. This is value of all measures, all interior angle, all exterior angle. To find out each exterior angle, we will divide 360 by n. N is how much? 5. We will get value of each exterior angle, which is 5 7 and 5, 72. Now we can get value of this, which is how much? 62, 78. So 78. No, 7 40. 108. 108. This is answer. So this will be 108. This will be 108. This will be 108. This will be 108, and this will be 108. Do you understand? So question was saying found out value of x. Found out value of